test flights are successful with the new frame. The prop guard needs some redoing, like a lot of redoing. Yeah, gonna figure that out. And basically, prop guards really suck because they're just like the least aerodynamic thing ever. So, yeah.
Hey everybody, welcome back to RC with Adam. My name is Adam, and welcome to part 2 of the Venn drone experimental quadcopter build that I've been working on here. And I made some changes and some updates. I want to get you up to speed on that. Here's the bottom line though. I'm starting to question whether this is actually a viable kind of quadcopter design, like if there's really much merit to this. It's fun playing around with it anyhow though. I have the plans, the STL files, available on my website that you can download for approximately exactly $0. So you can go and get those. And I do have two versions. I have the original version and then the newer version, which we're going to look at in this video. But first, I want to say thanks to my sponsor, PCBWay, for this video. In case you don't know, PCBWay makes custom printed circuit boards. That's what PCB stands for. And what you can do is actually send them a file of your circuit board that you've designed, and they will create that for you, which is pretty crazy. And they have a lot of different options. You can get super thick boards or flexible boards. You can actually have them assemble the board with the components for you. They can do that and then just send you the finished product, and that's pretty neat. And they also offer rapid prototyping services like injection molding, sheet metal bending, CNC machining, and 3D printing in case you don't have your own 3D printer. I've had them do some 3D printing stuff for me, and it turned out pretty great, and it got to me pretty darn fast. So if any of that sounds interesting, go check them out. Link down in the description to PCBWay.com. Tell them I sent you, and that probably won't do anything for you, but just let them know anyway, just for funsies. All right, back to this. Now, in the previous video, I talked more about the kind of the concept and original design for this quadcopter frame. And again, this is a 3D printed frame, and the idea is to have 5-inch propellers that overlap each other to basically have like a 5-inch quadcopter sized components and just cram it all into a small frame. Now, what I did not show in the previous video was flying this thing out in the open. We did some hover tests, and so here's a look at that right now. Yeah. So this thing was actually surprisingly smooth and steady, I mean, for what it was, and I haven't done anything with the PID tuning or any of that stuff, so I was pretty pleased with that. Now, it does sound horrible. It sounds very, very bad because we have a lot of dirty, disturbed air that's getting blasted through the propellers. I did a few full throttle kind of like punch outs and some flybys, and they sound really horrible. So honestly, the sound alone, I feel like might be a reason that you would not want to fly this near people, and it's just like a very distracting sound. And obviously, if it's making that much noise, that means we're losing a lot of efficiency. Like something is, not working like it should if it's making that much noise.
Sounds pretty crazy, huh?
I had planned to use Real Steady Go to stabilize the GoPro footage, but for some reason it just wasn't working. I don't know why, and that would have been a really big problem if this was like actually something that I really wanted to stabilize. Now you can see we do have some bumps, like just in straight and level flight, so we really shouldn't have bumps like that, kind of like wobbles. It may be because of the wind. It's pretty windy in this area. And then I'm gonna do some rolls and some flips and kind of see if there's like a lot of bounce back or prop wash. There is some prop wash, which I mean, that's kind of to be expected. And again, this is just like a stock tune, and we're running the new Speedy B F7 mini stack. So overall, I mean, for what it is, I was actually pretty surprised with it, pretty impressed with it. But I wanted to make some changes to the frame and make some improvements. So I hopped on good old Fusion 360 and went boop, 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 slice, 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 move, 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 numbers, numbers. What I've done is I've lengthened the frame. So I've sort of stretched it out by 10 millimeters. And that is just enough so that the two diagonal propellers will not touch. The propeller tips will not touch each other. And this is for 5-inch propellers. Now, the benefit of doing this is that we don't need as many spacers. So, because it's difficult to get the right screw length and all that stuff with all the spacers. And we're complicating things by extending the motors, you know, farther from the frame and farther from the center of gravity, all that stuff. So really it just simplifies it by getting rid of those spacers. And so now we can just have basically 2 levels of propellers. And I also shortened the top frame, or the top plate that covers the electronics and holds the battery. This design really isn't that great. I basically just mimicked the first design. But yeah, all of the smooth curves, it looks kind of cool, but it's not super great for mounting stuff. But that's what I did. So I dropped that down by, I think, maybe 5 millimeters. So it's just tall enough to clear the stack. Also, I added 20 by 20 holes in the front and rear of the frame. So this is still symmetrical front to back. And I made some various geometric changes to accommodate the new length of the design and all that stuff. And then I put it in the slicer and sliced it, and now it is time for printing. And then I printed it on the Focus Odin 5 using 3D Fuel Pro PLA filament in olive drab. And I really like their filament. And I think it turned out pretty nice. Now, since kind of the point of this concept is to use it like a CineWhoop, I needed to make some prop guards. Now, this is a pretty bad design, honestly, for prop guards. It's basically like a big basket, like a prop basket is what this basically is. So again, I designed that in Fusion 360 and then printed that one out. So I printed the exact same part twice, and then I just took the 2 halves and then screwed them onto the motor screws, which I actually had to get different length of screws, which was annoying, but that's how it goes. And then I zip tied the sides together. So that way you can print this out on the Focus Odin 5 bed, which is a 255 millimeters or 250 millimeters, I think. And now it's time to disassemble the old frame and put it all back together. And you'll notice the weight of the old frame with the spacers was 77 grams. And the new Venn frame with spacers weighs 71 grams. So we saved about 6 grams. And for reference, I have an iFlight Sedora SL5E carbon fiber freestyle frame, and that weighs 117 grams. And here I am assembling the new frame. I didn't do anything crazy special, just basically took the components off the old one and then slapped them on the new one. I did change out the XT30 connector that originally came with the flight stack for an XT60 so that I wouldn't need an adapter. And as you can see, we have about 1.5 millimeters of space between the 2 diagonal propellers. And the weight of the new Venn frame, all up with the GoPro and the battery, is 688 grams. And for reference, here's my current main quad with a GoPro and the same size battery, and it weighs 811 grams. And just for reference, the GoPro Hero 9 weighs 159 grams, and the China Hobby Line Speedy Pizza Drone's 1200 mAh 6S LiPo weighs 218 grams. And now that we have everything put together, we're going to do some indoor testing, and you're about to see me murder a LiPo accidentally. So I guess it was actually manslaughter. or liposlaughter. Anyway, now this is super unscientific, inconclusive data. I only did, one battery for each, but this gives us a very, very rough kind of idea of how this quadcopter will perform versus other configurations. So we're going to look at how it does without prop guards, with prop guards, and then we're going to look at a normal 5-inch quadcopter and use that for reference. We're going to see how long each one will hover for and also how loud each one is. And I think that's kind of an important factor that often gets overlooked. Now, I'm not going to make you sit through this whole thing, so let's get to the good parts. Without prop guards, and it hovered for about 5.5 minutes before it got down to 3.6 volts. Now, I kept flying because I'm silly and I wasn't able to read the voltage properly, and so I ended up killing the battery. So I ended up flying for about 7 minutes total, but I really should have stopped at about 5.5 minutes. Also, I'm not sure how accurate it is, but I put the amperage draw up on the OSD so that we can see that as well. And it looks like it maintained around 11 to 12 amps while it was hovering. And then, of course, it spiked up when I was doing those little punch outs and stuff. So as we can see, it says max current was 40 amps. It says we used about 1400 milliamp hours, but these are only 1200 milliamp hour batteries, so that must be off by a little bit, but the point is we used up way too much. Now let's see how that compares to my standard 5-inch drone. Honestly, it did pretty good. I hovered this one and did, a few little punch outs because I couldn't help myself for about 6.5 minutes, about 1 minute longer in flight than the Venn drone. Honestly, considering the difference in the spaced out propellers versus the overlapping propellers, that's actually surprisingly not a very big difference between the two. Now let's see how the Venn drone does with the prop guard basket. Another problem with this prop guard is that the way I designed it, it didn't print properly, so it's not actually tall enough to keep the motors from touching the ground when it takes off. So I had to kind of put it on a couple items to lift the motors up to take off. I mean, you could take off anyway, but you're just going to kind of scratch up the motors and scratch up whatever you're taking off of. Anyway, that doesn't really matter, but it's something to think about, I guess. Now, the good news is the prop guards do work. I put this piece of foam board up on the wall and bumped into it a bunch of times, and it worked pretty darn great. If those weren't guarded, it'd be chopping up the wall and, things would be bad. But it worked great, so that's nice. And it is totally flyable. Like, you could totally fly this like a little CineWhoop thing. But it's really loud. It's very loud. I was wearing headphones because this is just really, really loud. You'll notice that we are drawing a lot more current, about 30% more current, so around like 17 or 18 amps versus the 11 or 12 amps of the non-prop guarded version. And the total flight time is actually surprisingly close at about 4 minutes 50 seconds, so about 40 seconds less, which is kind of surprising. I'm not really sure how that works because we're drawing like a lot more amperage, so you'd think it would be a lot less. But anyway, now talking about the noise, here's a quick comparison.
Wow, that is so much cleaner. Oh my god. Definitely feels so much quieter.
And now it's time to take it outside for an outdoor hover test. I wanted to fly it with the basket on because that's kind of the point of this whole quadcopter, is you would have the prop guards on here. So it does fly, but man, was it getting buffeted around by the wind. It was quite a gusty day. And so, part of that is like to be expected. Okay, like you've got prop guards or ducks or whatever. Those just aren't going to do well in the wind. However, one of the problems with this prop guard design specifically is that there's just so much surface area, because it has to reach all the way from the top of the frame to the bottommost propeller, which is about, I don't know, I didn't measure it, but it's a bit. It's like 50 millimeters or something. it's quite a ways. So there's a lot of excess surface area and material for the prop guards, which really bugs me because it weighs more and we have a larger, footprint in the wind, so to speak, or surface area to get buffeted around by the wind. And I thought it was interesting how much movement there is of the prop guard when I'm hovering over the table here. You can see it's getting shaken like a lot. There's like a lot of a buffeting and shakiness, vibration in the prop guard, but that's only because of the kind of the downdraft recirculation stuff from hovering over the table. So once I get away from the table, it stops and it smooths out. So that's not too bad. It's not doesn't seem to terribly affect the performance vibration wise, as long as it has some clean airflow under it. I wanted to test out the agility with the basket on there, and as you can see, I tried to do a little roll, and this was a combination of that I didn't realize how low I had set the rates, and then also how slowly this thing would roll because of like the increased air resistance, and so I wasn't able to complete the roll all the way, and I ended up smashing into the ground, which was great durability testing for the prop guards, which is obviously the point all along. The prop guards, I mean, mostly it was intact, and it did seem to kind of, take the brunt of the impact, which could be good. It did break the prop guards, so I just peeled off the part that, was broken, and then I was actually able to still fly this, although that is not ideal. And I flew it around a little bit more, even with the, halfway broken prop guard, and I did a couple more like flips and rolls, and it performed, decently. But I have not actually taken it out and really like tried to rip around with the prop guard on. And honestly, it's been super windy, and it just kind of makes me think like, yeah, this thing just really isn't good for outdoors wind stuff. So kind of back to the drawing board on that one. So basically, the potential upside of this design, which is the compactness, is totally negated by the downside, which is that you have to have like this really large prop guard thing, at least this version of it, and that it doesn't really fly very well in the wind or with a prop guard. So so anyway, we could probably improve on that. If you want to improve on that, let me know if you want to design a new prop guard for that or something. Anyway, so there's some cool slow-mo of it flying and all that stuff. And then I also flew my regular 5-inch drone just to get a comparison. And honestly, this thing was getting buffeted around by the wind as well. So it wasn't just the Venn. But here's a comparison of just how it looks, because it looks really cool. And also how it sounds, because it's much quieter. And just for reference, for fun, here's kind of what is now sort of an old school CineWhoop. And this thing was flying like trash because I think I changed the PIDs around and I forgot to like update that for this setup that I just built. So ignore that. But you can get an idea for the sound. This thing is running 3-inch 5-bladed propellers and a 4-cell battery, because this thing is not 6-cell capable yet. The motors aren't made for 6-cell. So pretty pathetic, but kind of gives you an idea of, the technology just like a couple years ago. Pretty darn amazing. And all this brings me to the conclusion that I'm not so sure that this is a very beneficial design. It seems to create just as many problems as it potentially solves. But, that's how we innovate and, create new stuff and potentially solve other problems. So if you want to download this yourself and you can modify it, you can get that on my website at RCwithAdam.com, link down in the description. Just please do not, sell this design or don't steal my design, okay? Because I designed it. But you can download it, print it, play around with it. And just remember, if you've got some kind of cool design or thing that you need to create and you're like, man, this thing has got to be made, go and do it. Creators got to create, you know what I'm saying? Anyway, remember folks, if you put your mind to it, you can accomplish anything. That's what old Doc Brown told me. Thanks for watching, everybody. Stay creative, stay flying, and I will see you again very soon.
We get bars in our goggles that show.